Welcome again to the City of Constellation. This week we're going to talk about some of the improvements I've made on it this past week, and I'm going to talk about the difference between series and parallel circuits and the advantages to both types of arrays. First, let's talk about what I've done this week to the individual houses. I've decided, after a little bit of experimentation, that these photo cells that I was talking about last week, these little valves, if you will, decided that I did not need these. They were taking way too much away from the circuit. So instead, I went ahead and bypassed the photo cell altogether. I ended up going from this little black wire right here is the bypass. So now we're going directly into the PV array on the house, directly into the line. So I went ahead and let me reattach real quick. Actually, I'm going to do this. Let me show you what I'm getting out of this one little house right now. Now that we've made the improvement, I'm going to go ahead. Now, if you recall last week, all 5 of these houses collectively were giving me about 90 milliamps at when these things were in parallel to each other. We were getting 90 milliamps at 1.6 volts. I'm going to show you what I'm getting out of this now. I am now getting about 500 milliamps, half an amp out of this little house now. This little guy right here is putting out half an amp. Not well through the line. We're also charging this battery right here, and I know this battery is out of gas. So, I mean, this is what's coming through the line right now. 500 milliamps, half an amp. I'm going to go and show you how much voltage I'm getting out of this. Now, this is just one house. Now, let's remember this. 500 milliamps, 1.64 volts. Okay, now that's one house, and these guys are all going to vary. I've also discovered this little house right here. We've got a cracked cell right here. This one's cracked. I've tested this house is still putting out 1.6 volts, but I'm getting no amperage coming out here for whatever reason. I don't know. It's something about this cell is blocking any amperage coming out here. Maybe it's all going into the battery. Maybe the battery's completely dead and need to be recharged. But the point is that even though this is putting out voltage, it's not doing anything for us amperage wise. So that house is not doing much for us right now. So this is what we're getting out of one house. We get 1.65 volts at 500 milliamps. Yep, half an amp. Okay, now I'm going to go and plug this house back into the system. And as I do that, I'm actually going to come over here and explain the difference between series and parallel arrays. Okay, now I'm using Duracell rechargeable batteries, if you will, as my guinea pigs for this demonstration here. Actually, I'm not going to demonstrate anything. I'm just going to show you the difference between a parallel and a series circuit. Now, this is a parallel circuit. Parallel means that we have positive polarity and negative polarity, these black wires. The positive polarities, all these are tied in together, and all of these are tied in together to make one big battery. Now, what happens in a parallel array like this when it comes to power supplies is that we have, when you set them up in parallel, you're going to be adding your current capacity together. So with these particular, I use rechargeables as my example because they have a milliamp hour rating on these. These rechargeable batteries have a 2450 milliamp hour rating on these. So if we add these together, we'll get somewhere in the neighborhood of, I think it was 7,350 milliamp hours collectively. But we're going to keep our voltage. We don't add voltage when we do this in parallel, or in parallel. We add our amperage together. and we keep the voltage the same. Voltage will stay the same. 1.2 volts, 1.2 volts, 1.2 volts. All of these together, collectively, will throw out 1.2 volts. Now, let's go to a series array. Series array will have the negative, will have positive plugged into negative, and then positive on this battery plugged into the next battery, and so on. So this is a series. Positive to negative, positive to negative. And then if we wound up putting these together, the amperage stays the same. We're going to get 2,450 milliamps for sake of argument out of this, but we're going to get 1.2 volts plus 1.2 volts plus 1.2 volts. This is what you would see in most of your toys and most of your anything battery powered. Most of our battery arrays are going to be in series like this. Anything you're going to see in your consumer electronics, what have you, you're always putting your positive to your negatives, and you're going to series up the circuitry. What we're going to do here, I have two systems going on here. These three houses right here are all plugged in together just like this. They're in parallel to each other. So all of my positives are linked together, all of my negatives are linked together. Okay? Same on this road. I got positive linked together here, I got negative linked together there. This house is putting out 500 milliamps of current. This house is putting out 500 milliamps of current. And they're both putting out 1.6 volts of voltage. We're going to leave the voltage alone, so we're still going to get out 1.6 volts. 1.6 volts of voltage through this line. And we're going to get 500 milliamps plus 500 milliamps. We're going to total about 1,000 milliamps, or 1 amp. So let's put that theory to the test. Now let's bear in mind that these roads right here, that house isn't really putting out any power over here, so we're not, we got 4 fully functional little houses here. So this is 500 milliamps coming out of this house. This one's putting out 500 milliamps, well, in theory, I didn't test it. So let's see what we get. We are getting 921 milliamps. This little house, and I'll tell you this right now, the second house right here has a broken cell on it as well, but it only broke off a little piece of it, so it's generating slightly less amperage than the other one, but you know, 500 plus 400 and change gives me 900 and change. Our voltage, on the other hand, does not change. Let's test that theory. We're still getting 1.65 volts. So the voltage did not change in a parallel circuit. All right, I'm going to go ahead and go and plug this into the other circuit, the other row of houses, the other street, if you will. Now this has got 3 houses on it. 2 of them are actually doing something. .61 volts. Let's remember that number, 1.61 volts at 1,010 milliamps, just a hair over an amp. So we're getting a hair under an amp here, we're getting a hair under over an amp on this road. Okay, now that we got that, I'm going to go ahead and put these 2 parallel circuits together here. And I'm going to wire them up in series, meaning I got my negative here on one street and I got my positive on the next street. I'm going to tie them together. I'm going to tie them together. There we go. Now that we are in series, we're going to be adding our voltage, but our amperage should stay around an amp or so, about 900, somewhere between 900 and 1,000 milliamps. So I have this in milliamps, reading milliamps right now. Let's test that theory. There we go. We got about 950 milliamps coming through the system, so the math works. All right, now let's go and check our voltage. Now we're going to add 1.6 to 1.6 or whatever it was. I think it was about 1.6. We'll have to rewind and find out. 3.27 volts. The math works. So that is the demonstration of the differences and advantages of incorporating series and parallel circuits together. Now we're getting, like I said, we're getting 3.2 volts out of here. I want to ultimately get about at least 6 volts out of, say, a block of 12 houses. So I'm going to have 2 more streets. So I'm going to end up with 12 houses of 4 streets. That's what I'm going to consider one block. So in theory, we're going to be putting out about 6.4 volts, which I want a minimum of 6 volts. Actually, I want a minimum, absolute bare minimum of 5 volts, so I can run any logic circuits or what have you. Yeah, if that house over there was actually putting out any output, would be 1.5. 1.5 amps at no, the amperage would stay the same, because we're going to be doing 2 more streets in series with each other. So the amperage is going to stay around 1.5 amps if we have 3 houses on each street. 1.5 amps, 6.4 volts. So that's what one block is theoretically going to be putting out. Hopefully I'll have enough houses together in the next within the next week. I'll have a full block of houses going next Sunday. Granted that I can get past the 60 hours. This is why it's taking so slow, working too much. But there you go. That's my demonstration, and hope to see you next week with some more goodies to work with.